Walaikum assalam, Asif. Welcome, brother. Just give us 2 ticks, brothers. Just give me 2 seconds, I'll be back. Okay, brothers, I'm back. Okay, guys, so I'm back. You're waiting for the boiler service book? Rajinder, did you send me a message, brother? I'm not sure, I can't remember. I thought I replied to everybody. Alan, walaikum assalam. Can you do wiring on relay or a contactor? Thanks. We will talk about it, Alan. I should have done, but when I came back from work, this session is not necessarily fully organised, otherwise I would have had more. But I ended up finding one contactor in my van, so we will talk about it. It may not be a suitable one for the standard wiring system, but it will give us a concept of what we need to do. Okay, Rajinder. Okay, so I wrote your number down, Rajinder, so that's the only one that I missed, because I asked you to just send me a WhatsApp message, and if you can just send me a WhatsApp message, I will definitely send that over to you. My contact number, if you want to write it down, let me just put it on here as well. There we go, so you should have my number there. If you just drop me a line, I'll definitely share it with you. Okie dokie, guys, so today we set a bit of time up just to go through some wiring of different controls, connecting it to the boiler. Where do I live? I live in Bradford. So today's session is all about wiring different controls up with combi boilers, possibly system boilers, and we will touch on the contactors as well, the relay, the contactors, but it will be more to try to understand the concept and the switching arrangement on these controls rather than just follow what it says in the book, which you can do by all means. It's not a problem at all, but sometimes when a manufacturer's put something in place that's not self-explanatory, we get stuck. So it becomes very easy if we understand the concept instead, rather than trying to just follow a piece of paper and say, okay, number 1 goes to grey or grey goes to number 1 and vice versa. That's one way of doing it. But if we understand the concept, I think that makes it 10 times easier. So I'm not going to drag it too long. First of all, I want to say to you guys that I'm not a teacher. Far from it, okay? I have my way of explaining stuff, and I hope that it will make sense to you. But I want interaction, I want questions, I want you guys to say to me whether you have understood it or you haven't. And ask me questions, guys. I'm not Mr. Know-It-All. I'm sure majority of you in here will take part and help me trying to explain how stuff works. And I'm sure majority of you will have better ways than me to explain stuff. And you will know, or you do know more than I do anyway. So please please share your knowledge and information, and it's all about a collective effort, so we don't really need to just wait for me, okay, so to go through everything. If any of you, if somebody's asking a question in the commentary that I can't get to, please try to answer those to the best of your ability. And we're not here to degrade anybody, okay? We all know our own stuff in our own fields, and that's what we need to do. Just a brief description, or introduction I should say, not description, introduction. I'm a gas engineer, so gas is kind of my stronghold, been doing it for 16, 17 years now. Worked for various companies, started with heating installation, moved over to National Grid on gas emergencies, did that for several years, moved over to metering side with npower, with metering, to their auditing team, became an auditor, dual fuel auditor, from auditing to auditing manager. So kind of been to the other side, and then decided to come back, set up my own gas and electric company, and there's only two of us, so it's a small company based in Bradford, and we just go around, do day-to-day gas and electrical works. Like today we had an EICR to do, electrical installation condition report, a couple of boiler call outs that we did, and then we decided that I'll spend a bit of time with you guys this evening, just go through some of the wiring of different controls. So that's the plan. So I'm hoping that you guys will remain on board. You won't get bored too quickly, so have a bit of patience with me please, and we will take it from there. So Baz, yes buddy, try to remain busy as much as I can, although I have a young family to go back home to, but spending a bit of time, quality time with you guys, is what I thoroughly enjoy as well. No, as if not a problem at all. So first of all guys, what is it that you want me to make a start on? What I have here is a typical EPH wireless programmer, single channel programmer, and the receiver for it. Okay, EPH, thanks to EPH that they designed these for us. If you buy plenty of these, they can design your covers with your company logo and stuff for you, and on the inside of it, it does give customer a barcode to scan and the engineer's number as well. So that's quite handy. So we've got this receiver, as I said, wireless single channel. Same, very famous again with combi boilers and majority of the systems. An ESI thermostat, wireless single channel. The typical Honeywell mechanical thermostat. Oh, you got your burner up shed, but okay, fine. And then I've also got a receiver for one of the famous smart controllers or smart thermostat programmer, Hive. So we have a single channel Hive receiver here as well. So this is just the base, obviously, so we can look into it and see how to wire it up. We can connect all of that, if needed, to this boiler here. So we've still got our Valent boiler sat on the table, so we can connect anything to this if we want to. I'll put this box away, and then if somebody's interested in S-plan, Y-plans, I've got some printouts, and we can follow some of this stuff as well, just to see if this is something that you guys come across on day-to-day basis, just to try to understand the concept, to see how it works. Although I printed C-plan, but I don't think we come across C-plans anymore. Raise priority hot water. Yes, we can do that, although I've not printed a diagram for it. But that can be done as well. But I think we will leave that for another day, buddy, if that's okay with you. Today we're just going to touch on the simple wiring stuff, if possible, and then for future sessions, we can go to the priority domestic hot waters and stuff like that, and then we can kind of work with that as well. What I've also got in here, so I had two, but I'll get another one. So I've got some motorized valves. So we've got a 3-port, and we will have a 2-port somewhere as well that we will find, just to try to understand the concept of how the motor system or the wiring works on these. So that's the plan for today. What shall we make a start with, guys? Yes, Baz. So that was the intent. That's what I was looking at. So it's a matter of making something up, really, out of nothing, and kind of work with that. So, guys, should we make a start with the EPH control today? Are you all comfortable, or you want me to make a start with this? Because typically it's fairly simple, but it's just a matter of trying to understand of how it works. Should we make a start with that, or do you want to jump into the Hive base? You guys will dictate, I will listen, and we will just open one controller at a time and receiver and take it from there, guys. So are we okay with the EPH one? Yes, are you guys on board with the EPH? Okay, let's go. Perfect. Okay. So let's just open up the receiver. Let's just open it up and see what we find inside. Normally, that is what's covering the terminals inside. Let's have a look. I've got the screws underneath, as you can possibly spot. So that's why this thing came off, because I've possibly opened it up to demonstrate previously. So on here, guys, we have live and neutral. So that's our permanent live and neutral. And then we have 1, 2 and 3. 1 being off. I'm not sure if the camera is focusing properly. I'm not sure whether you guys can see it. Let me see if I can possibly point it down, and that way it may focus a bit better. Welcome, Usman. Yes, so EPH. So we have permanent live and neutral. That comes from the fuse spur, goes into permanent live and neutral here, and then from here we can loop it to the boiler as well. So the permanent live and neutral for the boiler can be looped from these two. Similarly, we can take permanent live and neutral to the boiler and then bring it to this controller. Either way, providing we have permanent live and neutral coming to this programmer base is energized. Then we have 1 common, and well, number 1 is off, number 2 is common, and number 3, as it says, is on. What they're telling us is, if you look at the actual... Who's knocking on the door? Okay, just... Thanks for cuppa. I'll just receive my cup of tea from my lovely nephew. Perfect, thank you. And a glass of water as well, just in case my throat dries out with these guys, just. And are you going to get me my keys as well before you lock up? Yeah, come on, keys. Perfect. Guys, going back to this, so number 1 and 2, if we look at it, we find that there is a connection. So it's normally closed switch, as we call it, between number 1 and number 2. So if we put a cable that's coming from the boiler, normally there's, most people like two cables coming from the boiler, PCB, for the thermostat wiring. So if we had one cable going to common and another cable going to number 1, what we will find is that when there's no demand on the programmer, the heating will come on, boiler will have a demand on. And the reason for it is because number 1 and 2 is a normally closed switch, okay? And then when we create the demand on the programmer, the heating will go off. So it's going to kind of work in opposite way to what we want it to work as. However, if we connect it between number 2 and 3, where it says on, that, if you can possibly see, is normally open contact, is normally open switch. So when there's no demand, this switch is open, and that's how we want it to be. We don't want the signal going to the boiler because there's no demand for heating. And when we create the demand, that's when this common number 2 becomes continuous with number 3, and our boiler gets the demand. So this is normally open and normally closed switch. Normally we have all the wiring for heating and hot water connected to normally open switches, not normally closed switches. Normally closed switches are for special purposes. We don't normally utilize them for wiring boilers up in a normal setup, in S plans and Y plans even. With yplan, there is an exception that we will get to slightly later on, but even with splans, we normally use open switches, which is when we look at the actual diagram where it's not making contact from one to another. So that's the normally open switch, and that's how we want it to be. So for example, if I wanted to wire this programmer, this EPH, with our boiler, our Valent boiler, I'll just shift this glass here, and let me just arrange some of my papers so I can move my camera closer to this boiler here. And guys, you will have to just bear with me with this camera angle and setup, please. We will get there. We will get there together. Okay, let's have a quick look. Okay, let me just remove this cover off PCB so we can have a better look. Let me just connect this up as well. So if we wanted to now connect this EPH receiver to this boiler, let's put it that way. Okay, so now if we wanted to connect or wire up this EPH receiver with this boiler, do I have a volunteer who can teach me how to do it? How would we do that? Can we take two cables from this boiler to connect there from any of these connections on this board? How would we do that? What do you guys think? And feel free to just give me your thoughts, guys. Common and 3. Live and neutral race. Yes, so live and neutral, obviously, we've got permanent live and neutral come into the boiler. We can loop permanent live and neutral from here and take it to permanent live and neutral there. So that, let's assume this programmer, this base, not programmer, this receiver is now energized. Okay, so Jay is saying link common and live. Number 3, back to the boiler RT. Are we agreeing with that, guys? So what Jay is saying is that this live, that's permanent live, we put a loop between here and number 2 common. So what we have done is we have provided permanent live to common, and then we have taken a wire from number 3 back to our RT connection. Now what that would do is permanent live is sitting at number 2 up until you create a demand. When you create a demand, this permanent live becomes continuous with number 3, and then that number 3 sends the 230 volt signal back to the PCB through RT, and the boiler comes on, the heating starts to work. Are we all happy with that? Live in neutral from the boiler to the start, then demand to the boiler on the RT240. Yes, that's correct, Alan. Definitely, that's the way to do it. However, in this setup, obviously, yes, that's correct, Alan. Definitely, that's the way to do it. However, in this setup, obviously, as mentioned earlier, live to common, and then we take load, or however you want to recognize it as, we take that back to RT connection, and that will do the job. Because RT on this particular boiler, normally you will find with Baxis and Ideals and Vaqueros, for example, we have a loop where it says RT. So one connection normally sends 230 out, another point receives that 230. We can literally remove that loop. We can take 2 cables from this position and then connect one to common and one to number 3, normally open switch, and happy days, it starts to work. With Valence is just slightly different. Valence only receive 230 feed back, signal cable back. So as it's only receiving it and it's not giving us a cable, we will have to put a loop in. and that loop normally would be between permanent live to common, and number 3 will come back and it gets wired into this boiler. So that's how we will wire up this EPH base to this boiler. This particular boiler that you're looking at now, it gives us an alternative way of doing it as well. Can anybody help me with that? Let's say we for any reason did not want to use 230 volts contact. So as we didn't want to use 230 volts contact, this connector, for any reason, let's assume this RT connection does not exist in this boiler. Guys, if this connection doesn't exist, can we wire the same base up? Low voltage contacts, exactly. Can we wire it up using this particular receiver that we're looking at? Raised 24 volts, exactly. Mother, thanks for all the following, guys, and the likes, keep that going. Jav saying 24 volts can be used. Point out, guys, where is this 24 volt? Where is the 24 volt connector here? How are we going to wire it and where are we going to wire it? So 2 and 3 to RT, 2 and 3 to RT. Kia, I'm not following that, buddy. If you can just elaborate on that, please. Remove B and off. That B and off, buddy, is actually burner off. So we don't want to remove that. This serves a purpose. If we remove this link, the burner will go off. The boiler won't work. And this is normally there for one reason I can think of on top of my head is the condensate pump. So condensate pump switch gets wired into here. So when condensate pump isn't working and it's flooded, it turns the boiler off. Okay, Asif, so remove RT. Okay, guys, so that's a 24 volt contact. I think it says it on the PCB as well, 24 volts. So we remove this RT link. Now when we remove this link, where do we take these cables to? So let's assume we connected a black and grey cable, one end of that black and grey cable onto here, and we've taken that black and grey cable back to our receiver. Now that we've taken it back to our receiver, where are we going to connect this? Common and 3. Perfect, Asif. Yes, common and 3. So what we do is we remove the volt-free contact loop. We put two cables here. One end of each cable. Contacts on our base, on our receiver, are volt-free. Because if these are not volt-free, with certain brands, certain manufacturers, you will find that the switches are not volt-free. They're 230 volts. And if that's the case, then you're taking a risk of damaging this PCB if you were to provide 230 volts through it, not realizing that is going into a 24 volts DC contact, and we are providing 230 volts AC to it, alternating current to it. So it can damage the board. So we need to be 100% that the contacts on our receiver that we're using are volt-free, which in this case are. So wherever we have volt-free contacts, we can just simply remove this loop, take it to those contacts and bring it back. Not a problem at all. When we have, let's say, a dual channel Hive receiver. Now a single channel Hive receiver has volt-free contacts, but a dual channel Hive receiver doesn't. So you're a beauty therapist and you're still watching it. We do appreciate it. I'm not sure whether it's interesting or it's my accent. Either way, you're more than welcome. Okay, so yes, so it is actually volt-free contact, and we can literally remove this loop, put a grey and black cable here, take that black and grey, put it to number 2 and 3, and then when we create a demand, our boiler should work. Guys, going back to the initial scenario where we started from, when we connect number 3 to RT, do you think we need to leave this 24 volts in, or we need to remove this loop? Perfect. So you get invested, so you do like lives. Okay, that's good. Asif. So I think we need to. Alan saying take it out. Asif saying leave it in. Now, only 2 weeks ago, in 1 week, I came across 3 Valent boilers, Ecotex boilers, where RT connection was being utilized with the programmer, but 24 volt loop was left in, guys. And when that happens, your RT connection is overruled by this 230 RT connection is overruled by this loop, and your boiler will have a constant demand. Paul, so you still prefer Worcesters? I went out to one earlier, buddy. I went out to a Green Star. And in fact, we have a CDI sitting just there that we will get to, but I'm not going to digress for now. Isn't it creating a loop? So as if this 24 volt contact has a priority over this 230 in a fashion that even if you have 230 switches come into here, if that loop is left in, your boiler will have constant demand. So we must ensure that this loop is removed if we are utilizing 230 volt into this RT here. Okay, so that's when we're actually controlling this point with the programmer. Yeah, definitely, Paul. It is definitely quick turnaround, easy money, and it helps customers as well. So breakdowns are really good. So going back to this wiring, so that will be an alternative way of wiring this up. Okay, guys, just a quick question. What if we had a receiver that we were using? We had a similar scenario today in the group as well, in our WhatsApp group, that the receiver being used was a dual channel receiver, although it wasn't needed for the task at hand because somebody was using it for the combi boiler. But let's say that's the only receiver they had. It was a dual channel receiver for Hive, and dual channel receiver on Hive, all the contacts are 230 volt, they're not volt free. And if somebody wanted to utilize that receiver with this setup, with RT connection, they will mess this board up, most likely. Can you think of a way that dual channel receiver that's sending 230 volts out can still be wired into our volt free contact or low voltage contact? Can you think of a way of doing that without making matters too complicated? Can you think of a way of doing it? So as if that's what you will do. You will most likely just use the heating contact. However, the heating demand or heating switch coming back to the boiler would carry 230 volts. Jarvis, it's an Ecotech, Valent Ecotech, buddy. So we are looking at a dual channel receiver using AC to DC converter. Okay, that will be one way of doing it, man. So I'm thinking of using a dual channel receiver. That's the only one. It's Friday afternoon. None of the merchants are open. I need to get this thing going. And I don't have a single channel receiver on board. I need to connect this dual channel receiver to this combi boiler. I don't have any hot water demand, so I'm only going to be using heating demand, which is absolutely fine. I can do. All I need to do is put a cable between number 4 and my RT connection, and when I create heating demand, it will come to 230 RT connection. Happy days. It will work perfectly fine, not a problem at all. The problem arises when my 230 connection doesn't exist, is faulty. I can't wire it up to here for any reason, and I may be making something up that doesn't exist, but for any reason, as and when that happens, and let's assume now that demand needs to end up somewhere here in this 24 volt section. In commercial setups, in commercial boilers, majority of the time we find that the only thermostat connections or controls that we have is volt free contacts. We don't have the luxury of 230 volts. So if that's the case, and my receiver is only giving me 230 volts contacts, it's not giving me volt free contacts, how can I still wire this up here? How can I still do it? Okay guys, so I don't want to leave it till too long, but I'm going to show you something which majority of my gas engineer friends may not like, and they may say, oh, that's electric bull. Okay, it is electric stuff, but there is a possibility that it can be done. Okay, it can be done using a very simple contactor. The one I'm going to show you next is not a simple contactor. It's actually a 4-pole contactor, and to those who have not seen any contactors before or used them, it may come across pretty daunting. Okay, don't worry, it's a very simple switch, doesn't cost a lot of money. A 2-pole contactor, 20 amp 2-pole contactor, we can pick one up for about $9.99 from Screwfix as well, or $19.99, either way, from between 10 to 20 quid we can pick up a contactor that then resolves this problem for us. Okay, although I said it was a Friday evening, none of the merchants were open, but let's say we had a contactor on board as well. Okay, so by using a contactor of something similar nature, we can do that. All this contactor does is we can power or energize the actual coil inside this contactor using 230 volts, which is A1 and A2. It's not volt sensitive, so A2 you can put permanent neutral. A1 we can use the switch live that was coming from number 4 that was carrying 230 volts, and we can put it to A1. Now that we have control over this coil, and this coil is being controlled by the heating demand from your programmer, what we can simply do is all 4 of these top connections have a volt-free contact with all 4 of these bottom connections. We only need 1, we don't need 4. But what we're going to do is we're going to remove the link of RT. We're going to put one cable in number 1 and another cable in the opposite connector number 2. And although to those who can read this may say it's completely opposite, which we will get to, but in a normal scenario, if this was a normally open contactor, number 1 and number 2 will touch each other, will become continuous when you create a heating demand, because what will happen is when you create a heating demand, 230 volts will come from your number 4, go into this contactor, energize the coil, which will then connect number 1 to number 2 and not use any voltage on these contacts. So literally that loop that you have will become a loop through this contactor as soon as you create a demand. That's exactly it. That's what it will do. So the start does that without this extra switch. Yes, a start can do that as well with the extra switching. But this is when you don't have the luxury of being able to utilize 230 to turn it into a signal cable. You can use a contactor to do that job. We will elaborate on these contactors. I will definitely find a standard 2-pole contactor, which is half of this literally, just 2-pole standard contactor, and then we can make it work. Alright Baz, you take care buddy. Thanks for staying with us so we can make that work. Okay guys, so that's just to touch on contactors really. Nothing special. It's not too complicated, but we will get to that. Going back to our scenario, let's move that. We were on the actual EPH thermostat. The 230 on EPH just allows it to receive from controller and doesn't put 230 on PCB. That's true, David. Definitely. We were actually creating a different scenario, but you're correct in saying that live and neutral, permanent live and neutral to the receiver, and then these contacts are contact free. So literally, if we remove that loop and take it to common and 3, that will become our switch. We don't need to worry about anything else. So that'll definitely do that. Perfect. Now, should we remove this now and use the ESI receiver next and see how the switching on that works. So let me just put my phone in here so I can open this up. I think it's open. We can have a look at it. Okay. So here we are. We have neutral, live, 1, 2 and 3. On the actual base we see neutral, live, 1, 2 and 3. I'm not sure if we can focus it. I'll try to put my hand behind it so you may be able to see it. Okay, so we've got neutral starting from left to right, neutral, live, 1, 2 and 3. Now looking at the actual label of what it reads, neutral and live is permanently neutral and live. That we needed for EPH, for this programmer or this receiver. We need that 230 volts come into it to energize for all the electrics to work inside. Now number 1 on this is common, whilst on the other one, common was, which one was common? Number 2 was common. So this is where when we try to memorize, let's connect it 1 to 3, let's connect it 2 to 4. This is where things don't work out then when we used a different control, where the manufacturer just designed it slightly differently. But if we understand the concept, then it doesn't matter whether number 16 is common and number 19 is normally open with that common. We can easily work that. So number 1 is common on this. Number 2 is normally open / on. Okay, so normally open / on is telling me that this will become continuous with number 1 with common as and when there is a demand created. If there is no demand, it's normally open switch. So in a normal scenario with no demand, this switch will remain open. Okay, so where we were connecting number 2 to number 3 with EPH, here we are connecting number 1 to number 2. But we are literally connecting, walaikum assalam brother, we're connecting to a normally open switch, and that's all we need to know. So common gets connected to a switch which is normally open to common. Similarly, if we connect it to normally closed, number 3, so if we have a connection between 1 and 3, that's normally closed. So if we connect 1 and 3, that will be normally closed. So if we check it now between number 1 and pin number 3, we should have continuity. We should have continuity there. We don't want that, because in normal circumstance with no demand, we don't want that signal to go to the boiler to turn on. We want to wait till when we create a demand, and that's when we want the boiler to come on. And if that's the case, then we will be connecting it to a normally open switch. So if we are connecting this base to our boiler, what we're going to do is we will provide live and neutral to it. Once we have given live and neutral to its own points, then the common, which is number 1, depending on how we connecting to this boiler, if we are connecting it to RT 230 volt contact, then we will provide a loop between permanent live and number 1. We want to bring our permanent live to number 1 through a loop, and then from number 2 we will take a signal cable back to RT connection on our boiler, and when we create a demand, the 230 volt which was sitting on number 1 on common will travel through number 2 and turn our boiler on for us. So that's how we will do it. So as if saying that is just like the link on RT low voltage if connected to 1 and 3 instead of 1 and 2. So as if yes, so that's a permanent link, but it does break when we create a demand. So a normally closed switch will become open when you create a demand. So it works in reverse basically. So that's how it works. So if we now need to connect this receiver, what we will do, you get confused with wiring, and this session is to try to eliminate that confusion really. I really hope that I'm not going to make it more confusing for you guys, and that's where I need you to participate. But yeah, so that's what we will do. So what we will do is we will put a loop between live to 1, and then we will take a cable from number 2 to our RT connection. So that will be one way of wiring it. Another way of wiring it will be in that volt-free contact, the 24 volt contact that we had. If we are using that, then we don't need any loops. We can just provide permanent live and neutral to permanent live and neutral points. And we know that our normally open switch is number 1 and number 2. We will literally remove the loop from our PCB 24 volt contact, and we will bring it here and connect it between number 1 and number 2, and as and when we create a demand, it will start to work. Now, it doesn't necessarily have to be a 24 volt loop that we bring in here. We can by all means bring 230 volts to number 1 and take it back from number 2. Either way it will work. It doesn't matter to the receiver whether the signal being brought to it is 230 or 24 volts. What we need to be careful with is that the contacts on our receiver base, whether these are 230 volt contacts or these are volt free. If these are volt free, it makes it a lot easier. If these are 230 volt contacts, then we cannot put these signals or these switches back to our PCB in the low voltage section. So this is where we need to be very careful. I hope that makes sense, guys, but it doesn't, let me know and we can go through it again. Okay, so that's what we need to do. So if we are connecting this base to it, to this particular boiler, we can again do it two ways. One is to put a loop, and second will be to connect it directly to the 24 volt contact without a loop. So that's what we need to do. Okay guys, there's quite a few of you watching, which I highly appreciate. Please keep those likes going. If not, the tiny dinosaur that I put up there, it just helps the channel. It attracts more viewers, which is really good, that we can share this knowledge with more people. So please keep that going. So normally 230 volt connection, definitely. Why is two options with low voltage and 230? What does it mean? So it depends on the boiler itself. Now in this particular boiler, we can wire it up as 230 volt contact or a 24 volt contact. Choice is ours. We can utilize it either way. In certain boilers, you don't have that choice. You may only have 230 volts contact for your thermostats, or just low voltage in commercial setups. So just commercial, mainly commercial, you will find that majority of switching is just volt free, as we call it. So it depends on how we want to wire it up, really. So that's what it comes down to. Okay, are we good with that, guys? Should we move on to the Hive base next? Okay, so let's just move on to Hive base next. Guys, before that, before Hive, how about this baby here? I still find them every now and then. Are we all familiar with how to wire these up? Sparky, we will get to Hive straight away, buddy, straight after this one. Or should we skip this and go to Hive instead? Okay guys, so I think you guys just wants to go to Hive. Okay. Let me just pick up Hive, guys. Okay, so we have a Hive receiver. We have a Hive single channel receiver. Guys, we've selected now. Sorry for the Honeywell guys. You will have to just wait a little. We will leave that till the end. That's literally two connections, guys. It's just an on-off switch. You can literally use a light switch for all I care to just turn your boiler on and off, and that's what that is literally. But we have a Hive receiver. We'll open it up, and look what they've done to show us it, except if we open the book and look at it in there. But they couldn't have made this any smaller, guys. They couldn't have made it any smaller, I'm telling you. And they do it deliberately, you know. They do it deliberately, so us guys, we have to get our glasses out and we take it close to our face like that and try to figure out, and then it still blurs and we still can't make it of what it says, okay? But what it's giving us there is that neutral and live, obviously, so that's permanent, neutral and live. I'm going to stop talking about this permanent, neutral and live to these bases in a second, and I'm only going to talk about switches. But what it also shows is number 1 and number 2 is a normally closed switch, which means number 1 and number 2 are continuous as we speak without a demand, and number 3 is normally open. So when we connect it up, and let me just have a quick look on this piece of paper because I don't have my glasses on as well. So that should be the wiring for that we see now. So number 1 being common, number 2 to common is normally closed, and number 3 to common is normally open. So again, as I said at the beginning, we always go for normally open switches. So what we want is number 1 and number 3. Again, guys, numbers don't matter whether it's number 1 and number 7. What we need to establish is what's common and what is normally open to that common. As far as we have figured out those 2 points, our job's dead easy then. So raise very fast, buddy. Perfect. So what we're going to do in this setup here is we're going to create a loop because of our boiler at hand. This boiler is not sending 230 volts to receiver and then taking it back through other cable. Because this boiler only takes 230 switch in and it's not giving us anything to work with, we then have to provide a loop. So we literally need to provide a loop between permanent live and number 1. So we're going to put a loop between permanent live and number 1 here. So now we have put permanent live to number 1. But that's not doing anything, that's just waiting there. Because number 3 is normally open to this permanent live, number 1. Up until we create a demand, that live will not become continuous and it will not travel to number 3. Hence there's no demand. As soon as we create a demand, number 1 becomes continuous with number 3. Number 3 is then connected to the RT connection on our boiler, providing our 24 volt is removed from valence. Your boiler is then controlled using this receiver. Rajinder is saying, does any effect of 1 use 1 and 2? So if somebody uses 1 and 2, Rajinder, this receiver will work in opposite way. So when there is no demand, this receiver will send the signal to the boiler, so the boiler will remain on. And when you create a demand or the thermostat is satisfied, the boiler will go off. So when it's not satisfied, I should say, in opposite way. So when the thermostat is not calling, the thermostat is not given a demand, the boiler will remain on. And when thermostat is calling, the boiler will go off if we connect it to 1 and 2. Depends whether heating or cooling, exactly, better way of putting it, buddy. So yes, it depends on what we're doing. If we want heating, it will be 1 and 3. That's what we need. Are we going through Worcester boilers too? We've got a Worcester on the floor there, guys. We can switch this to a Worcester and have a quick look inside if you want me to. But for time being, our plan was to go through these thermostats with this boiler because this provides us with the RT connection 230 volt, and it also gives us a volt free connection. So it kind of covers both sides. So let's see. Let's just complete this, and then we will see if we've got enough time to switch over to a Worcester or a Vaquera. Either way, we've got a Vaquera sitting there as well. Vaquera seems a bit lighter to me. So like I use 1 and 2 ESI, you use main RT. How would you do a multi-room thermostat? So a multi-room thermostat, obviously it requires its own receiver, and each thermostat will have its own receiver base, or it will be connected separately. So each room will be calling for heat. Now for a multi-room thermostat, it's not just a thermostat. You then require multi-zones as well, obviously, because if you are controlling a different section in a building, then you're splitting the heating circuit into 2 or 3, for example, depending on how you want to control it. So you will either be controlling the zone valves for that area, or you will be controlling the TRVs. Either way, you will be redirecting not just the wiring, not just the power to the boiler, but also the flow of water as well. Okay guys, so are we happy with this hive of how we're going to wire it up? Are we okay with that? Any questions, guys? Okay, perfect. So as you're all happy now, I'm going to move on to a dual channel receiver base. We touched on it earlier, but let's just say we didn't have a single channel receiver on board and we only had a dual channel receiver. Now, first question, without using anything external like contactors or anything like that, if we had a dual channel receiver, can we utilize that? Can we run that to a volt-free contact? Can we wire it up to a volt-free contact on our board today? No? So whoever's saying no, could you elaborate why can't we do that? And Alan's saying yes. So Alan, why do you think we can do that, buddy? So, alright, just saw you off now, yeah? Okay, thank you. Have you locked the man?
Yeah.
Perfect. Okay, so to those who are saying no, could you please give me a reason of why we can't do it? And to those who are saying yes, can you please give me a reason of why we can do it? Bearing in mind, I'm only going to tell you one difference. It's not a trick question, buddy. The only difference, or one of the main difference between a single channel Hive receiver and the dual channel Hive receiver is that on a single channel Hive receiver, your 1, 2, 3, and although 4 is unused, these are volt-free contacts. So there is no power running through them except if when you want to run any power through it, or I should say 230 volts. On the dual channel receiver though, you have 230 on all of these contacts. So these are not volt-free contacts anymore. Yes, Osman, you're saying unless we use a contactor. So the reason we can't connect a dual channel receiver directly to our volt-free contacts on our PCB or any boiler is because on a dual channel receiver, all the contacts that we have to work with are 230 volts and are not volt-free anymore. So this is where we need to be very careful, guys, because we could be installing, we may have spent a full day or day and a half on installing a boiler and this lovely heating system in this customer's property, and then where it comes to literally just wiring a programmer up right at the end, towards the end of the job, and we have a dual channel receiver that we didn't look close enough or closely enough, and we wired it up to a volt-free contact on our boiler and messed the whole PCB up. So this is where we need to just have a quick look at manufacturer's instructions and make sure that the contacts that we're using Aero 27 and Wayland Pro 28, exactly, buddy. So we just need to make sure that our contacts that we're utilizing are volt-free. Okay, so this is where we need to be very careful with all of that. So if you're using a dual channel receiver on Hive, what we want to ensure is that the simple way of doing it would be no loops required on this one now, because we have 230 volts traveling through the contacts already. So heating on, if you're using it for a combi boiler, take a cable from number 4, put it in RT section 230 RT on your boiler. Happy days, it does the job. When you create a demand, it will just do it. You want to put a timer on your immersion heater? Is that possible? Of course it's possible, buddy. You either need to buy a timer that will carry that kind of current, or you simply control it using a contactor. But there is a way of doing it. You need a Sparky, or if you want to do it yourself, I don't encourage that you do it yourself, except if you're a competent person and you know what you're doing and you can safely do so. But otherwise, an electrician can simply install a 20-30 pound worth of a device like that, and then you can basically attach any thermostat or programmer to it. You can literally install this Hive or a smart control to control your immersion heater. Anything is possible using contactors, really. So Rajendra saying, I used combi main boiler wire, take grey and black, put ESI thermostat, 1 grey, 2 black wire. Yes, Rajendra, that will work perfectly fine if you did that. So that will work perfectly fine. That will also work perfectly fine with this receiver, a single channel receiver. If you put a black in number 1 and grey in number 3, or either way, it doesn't really matter which way you put it. So that will work as well. And it will also work the very same way with EPH, providing you put black and grey in number 2 and number 3. So yes, you can connect those cables to anything really, providing you have one bring in 230 volt and one take in 230 volt back to the boiler. So that will just turn into a loop. So it is possible. So this is how we will wire this up really. With the dual channel, as I said, the only difference will be these are 230 volts contacts, guys, and that will only give us 230, so we need to make sure that we actually put it in 230 volt contacts, guys. Guys, 103 people watching, 2.7k likes. Can we top that up to at least 5k if I'm not being greedy, guys? That's just to help the channel. I know you guys are tired and your fingers are tired as well, but it will be highly appreciated. Thank you. So keep that going. That keeps me encouraged. That helps the channel. It'll be great, guys. Thank you very much. Okay, so going back to the control. So that's how we wire these up, guys. What else? Let's just close this boiler back up, guys. Let me just move this contactor. Okay, go back in there, go back in there. Okay. Now, let me see what I have in here. Just move this heater out of the way. And let's see what is it that we can work with. Let me just disconnect the cable out. Just all nice and safe. It wasn't turned on anyway. What days am I live? We haven't set any days up yet, buddy. So it's just as and when I get a bit of time, really. Contactors, what do I use them for? I use them mainly in commercial setups to connect even smart controls to commercial boilers where we have multiple pumps and we have the backfeed problem. So I use them for that. I use them for heating, certain heating requirements in commercial setups again, where the standard switches and buttons and programmers won't do the job. So guys, 4K likes, thank you. So take a bit of rest, and in a bit we need to top it up again, guys. So take some rest. Okay guys, so let's just move on. What do you want me to take to this table next? So we can move this. And what do we have here? Guys, my boiler den will tell you something about me, that I like these things quite a lot. Okay, valence you will find all over the shot. And I picked this up purely for you guys, just for demonstration purposes. I picked that up, not a fan of these things, but they're out there. We can work with them, definitely. And what do we have here? Who recognizes this baby? Baxi ideals. I did have some Baxis that I've stripped already, and I did have some ideals as well, and I can prove it to you guys that I did have some ideals. Have a look there. Have a look at that. So we did have some. So guys, what we can do is, again, it's up to you. We can take this boiler to the table, we can take this Worcester to the table, but either way, no matter which boiler we take to the table, the wiring will remain the same. Each boiler, each model is normally different of where we put the connectors, okay? I have not memorized all the models and all the boilers, if I'm being open and honest with you guys. All I do is, no matter which boiler I'm installing, I just have a quick look at manufacturer's instructions, and it normally tells me where to put these connectors or how to wire it up, and I just follow that. And provided I understand the basic concept of the controls and the programmers that I'm using, we can just make that work. So that's how it normally works out. So John, you're saying Worcester heat only boiler. I don't have a heat only boiler, buddy, unfortunately. We can create a scenario for definite. A heat only boilers doesn't have a pump, so we will have an external pump connected, and then obviously we will have to turn it into an S-plan. And cylinder starts. So again, cylinder starts, guys. So let me just clear this table slightly. Okay, guys, so let's just clear a bit of this stuff from here. Just move it out of the way. So John Dutpati, my nephew made that for me, thanks to him, and it is nice, it is very nice. Okay, let's see, what do we have? Let's see, what do we have in our Mother Hubbard's bag, guys? Shall we have a look? What do we have in here? Okay guys, which one should I pull out? Okay, let's see. Cylinder start is what I was asked to pull out. So cylinder start is here, guys. Okay, I'm not going to have to just adjust my camera slightly. Bear with me 1 second, please. Okay. If the camera angle is wrong, just shout out, guys. Just tell me. I'm not a professional cameraman. Okay, so let's see what we have here. Where's the screwdriver? So guys, we have a cylinder start. It's a Honeywell cylinder start, and let me just move this slightly here so we can see a bit better, obviously. Okay, perfect. So connections within this cylinder start, let's just open it up and have a quick look. So we can wire it up as a switch. Oh, it's a broken one here. So we can literally wire it up as a switch 1 to 2, or depending on whether we have a different setup, whether it's a yplan, then we will need all 3 points on these. Okay, I mean, now it depends on how we test in and what we test in it for. If our water is boiling literally, we know that our cylinder starts 9 out of 10 failed. So that will cause the boiler water in the cylinder to boil. And if we don't have hot water not coming on, again, we can try to find if the cylinder start is what's causing it. So that's what it will be. Guys, just bear with me 1 second. Just bear with me 1 second, please. Hi brother, how are you? You may find me talking to myself in there.
I said I could hear something.
I'm not going to loop here.
So let's move in here.
No. It's just my boiler then. How are you?
No, good.
All good. So I just need to go back to my TikTok live, brother. No worries. Okay guys, I'm back. Okay, so sorry about that. So talking about cylinder starts here. How to diagnose when the cylinder start fails and wiring cylinder starts on mega flow. For S-plans, very simple concept, or very similar concept I should say. So on the cylinder start, we have 3 connections on this particular one, and we will keep it nice and simple to start with. So let's just remove one cable. In fact, just assume that it's only got 2 cables connected to it, guys, no 3. Okay. You could hear us. Okay, perfect. So it's just that somebody in the next room just came in, and they don't normally hear me whilst I'm in here. And I just went to say to him that, look, don't worry about it. I'm not going to loop him. I'm not talking to myself. But it was just that. Okay, so this is the cylinder start, and to demonstrate it, we can have a quick look at S-plan, because that has a diagram for the cylinder start, guys, and it's literally 1 and common, 1 and 2. Okay, so all we need to do is we need to find a point on this cylinder start where we can just connect our cables to. Now inside of it, I may not be able to focus it for you guys. We'll try. But anyway, in there we have common 1 and 2. Now common and 1 and common and 2. Let's see which one is normally closed and which one is normally open. Again, it's a start, guys. It's a thermostat, okay? If it's a thermostat and we need to utilize a switch, tell me which switch would you go for? A normally closed or normally open? If it's a cylinder start, which one would you normally go for? Okay. So I have just established, using a multimeter on standard buzzer setting, that this being common, the very first one being common, is a normally closed switch with the one next to it, which is number 1, and it's normally open with number 2. So let's say this is number 1, this is number 2, this is number 3. Okay, so if this is number 1, number 2, number 3, we have number 1 being common, number 2 being normally closed with common, and number 3 being normally open. So now when we create a hot water demand and this thermostat is on the cylinder, and the hot water within the cylinder, or the water within the cylinder, is not hot, we want this thermostat to be calling for heat, or to be calling for the boiler to be on. So we need that switch to be closed. We don't want that switch to be open. Okay, up until this thermostat is satisfied. So although there is a demand coming to this thermostat from the programmer, but once this thermostat is satisfied, we have the desired 60-70 degree temperature within the cylinder. We want this thermostat switch to break in a fashion that is not continuous with number 1 anymore. Hence, it will turn the boiler off. So what we want to do is we want to connect it to a normally closed switch, not a normally open switch, because if we connect it to a normally open switch, it will work again in opposite way to what we desire it to work as. We want it for heating, we want it for hot water, we want the cylinder to be warming up when the cylinder start is calling. Okay, so that's how we will check it. Now, how do we know if it's working or not? Simply by, if you're just checking whether it's passing or whether it's continuous or not, depending on thermostat, this is broken by the way guys, depending on thermostat, if you have an off position, you literally take your thermostat to off position. In off position, your common and your normally closed switch should have no connection, and when you turn it on, these 2 points should become continuous. So and how to test it? Using a multimeter. You can use a multimeter, and this is a dead test, so you can literally check it by just using a multimeter, and that will tell us it's broken, so it's just acting funny right now. But that's how we will check it, by the way. Now another way of testing it would be is whilst everything was live, and we do a live test, so we can check it in the actual junction box where the thermostat signal was traveling to before it went to the motorized valve, or where it goes to the motorized valve. So that's where we can check it. So if I can just show you this picture here to make it slightly easier to understand. This is a simple S-plan, and I'm sure if any of you guys, whenever you search or look for an S-plan, this picture is something that we normally look at. So we have a time controller right at the bottom here. And we have the programmer or time controller. Let's say we created a hot water demand. When we create a hot water demand, 230 volts travels from hot water programmer to our connector strip or our connection or junction box, whatever you want to call it. It comes to our junction box. What it's actually going to is the thermostat, is the cylinder stat. It connects to cylinder stat depending on what the cylinder stat is doing, whether it's satisfied and this is in open position. If this is in open position, it's not passing any message to the other side. But if the cylinder stat is not satisfied, the water is still cold, the cylinder stat has a connection between one point to the other, and then that 230 volts travels through to our zone valve, which is the brown of the zone valve, going to the motor. That's all it does. So if we were doing a live test, for example, I will turn the hot water demand on, and I will go to my junction box. I will locate where that cable is coming to from hot water, and it's connecting to the thermostat, and then where it's coming back from the thermostat to go to my motorized valve, I will check for the voltage here. I will check to make sure I have 230 volts when this cylinder stat is not satisfied. If that is the case, then the cylinder stat is doing its job. Cylinder stat is calling for water to be warming up. It's telling the motorized valve to open up and turn this orange live and send the signal to the boiler and the pump. So that's how it should work. So cylinder stats can work in that way for S plans, or if we had a Y plan, then we will be using all 3 points for it as per here. But I think we will leave S plans and Y plans for another day when we can look into it in a bit more detail. There are good videos about these. The only problem with watching videos, and I've seen quite a few videos on YouTube as well, the only problem that I find is sometimes whilst you're watching a video, you come across a scenario where you think, oh, I want to ask a question, or I want to discuss that slightly further, or I've not understood it 100%, or I know the concept but I've not understood it. This is where a live session then is handy, that we can try to understand what's actually happening. Okay, so we can actually get to that. So that's the cylinder stat, guys. I think quite a few people are leaving us now because we are boring them to death with all of this. So what we want to do is we want to come back from cylinder stats, and we want to look at something interesting. Am I going to cover the twin stats? So twin stats work in the exact same manner, buddy. It's the exact same principle, because what's happening is in the twin stat, we have an overheat stat and a thermostat. I've gone to pen and paper now, guys, for you guys. What's going on? Let me just see. A twin stat will literally be a combined unit with, let's say, overheat and thermostat. So it's a combined unit. What we're going to have a programmer. So we have a programmer here, and from the programmer now we want to have, let's say, hot water demand. Hot water demand will come to one side of this twin wire thermostat, or twin thermostat I should say. Between one thermostat and second overheat and thermostat, you normally find that there is a built-in loop, and then the other side will go to our zone valve brown. So if this was our motorized valve, this will be the brown cable. So that's how I understand these. So when we have a demand coming from the programmer, it goes to one side of the stat, it travels through the loop to the other side, and then it comes to our zone valve to turn it on. If overheat thermostat detects that the cylinder's overheating for any reason, it breaks that connection, and this power that was coming, it will not go to the second stat. The boiler stops working because zone valve moves to off position, orange becomes no voltage, and the signal is lost to the boiler. If overheat stat is not activated and it remains in on position, the thermostat does its job, and the thermostat detects the desired temperature and it makes and breaks accordingly once it's kind of got to that temperature. So that's the simplest form of twin thermostats. I don't think there is anything else to it, and I hope it makes sense. But I don't have a twin thermostat to hand right now to demonstrate it to you guys. But that's how it will work. It's as simple as that, really. It's nothing complicated. We just need to, with certain twin thermostats that we buy, especially the ESI ones, we have to be very careful, because some contacts or some points where we connect the cables to, they may look to be live or neutral, but they are actually earth. So we need to be 100% on those. But that's how it actually works, guys. Okay, perfect. So that's that. Somebody mentioned earlier some simple fault finding using a multimeter or using a tester. Again, it all depends on what we're looking for, guys. What kind of faults do we have? Some faults, again, wiring faults, can be very simple if we use the logic that goes behind it. If we have the logical approach to it, sometimes you will find that fault finding is very simple. Honeywell thermostat, the hardwired to the boiler. Simple stuff. Here we've got a Honeywell thermostat. Let's just open it up and have a quick look. So we've got quite a few contacts on this thing for what we normally use it for, but on the actual label it tells us that number 1 is where we're going to take our live to, and number 3 is where we can take it out from. So it's a normally open contact, and when we create a demand is when it will come back on, or it will come on for us. Guys, I have a bulb here, a light bulb. Do you think we can wire it up through this? Do you reckon? Let me just see. Normally open and normally closed. Okay. Guys, who wants to wire up this light bulb with this thermostat and control it with this thermostat? Who wants to do it? Should we give it a go? Okay, perfect. Let's have a quick look. Let's see. Let's see. Okay, I'm just preparing the cable, so if you bear with me 1 second, guys. Live and neutral is what we're using. We're not bothering with CPC or earth connector right now. Where am I located? I'm based in Bradford, Bury. Guys, you guys stopped liking now. We are only at 6.4k. We need to top it up to 10 if possible, please. Okay, let's see. Neutral connection. We need to provide a permanent connection to this switch. So let's just connect neutral to neutral. So neutral is going direct. So neutral's gone direct. Our incoming live is going to number 1. If you bear with me a second, let's see. Guys, in a second we're going to be turning this light on and off with this mechanical thermostat that we have, that we normally use to switch boilers on and off. Okay guys, so first of all, it's all switched off right now, so we don't need to worry about it. But all I've done is I've connected a neutral, obviously directly as it's coming, so that's gone there, and then the live, permanent live, is coming to number 1 and it's coming out of number 3 going to the light bulb. So this is the exact same concept that we would like for our boiler to come on and off, really. So let's have a look. I'm gonna then now plug this in. Just grab my extension lead. Okay. I've got the extension lead. I'm just powering it up. Okay guys, so now we have some power coming to this switch, or I should say this thermostat, and this bulb's here. What's going to happen if we turn it? Guys, should we do it? One, 2, 3, go. Okay, there we go, perfect. So now what's happened is the demand's gone to our boiler and the boiler's switched on. We have connection between 1 and 3. So permanent live that was coming to the thermostat is now gone to the boiler, or a light bulb, as you can see. And when this thermostat reaches the temperature, it turns it off automatically, or a customer then turns it off using the thermostat. So that's all there is to it. It's as simple as that. Now this concept is exactly the same for any thermostat out there. Almost similar guys. So whether we're using a mechanical thermostat, we can do the exact same thing using a Hive receiver. We can use the exact same thing using the EPH receiver, or an ESI receiver, anything. So now if we wanted to do the same thing to this EPH, how would we do it? How would we do that, guys? If we wanted to control this light bulb using this receiver, how would we do that? What do you reckon? One and three, but can we just do this to 1 and 3, fella? because it's not going to work, as the receiver requires live and neutral as well. Live and neutral 1 and 3. Yes, Usman, exactly the same way. We can just turn this bulb on and off. Let me just see if I can quickly do it for you guys, as the concept remains the same, whether it's the mechanical thermostat or any thermostat for that reason. So we are taking load, as we need to close this back up as well. Let me just come from behind it, guys, here. So I've got my load or switch cable that's going to the boiler connected in number 3. I need permanent live and neutral going to, let me see if I can find some cables, guys. No, I've got some cables here. Sorry, I'm going to be using wrong colours for this demonstration, but let's see. Oh, I thought I had some cables. Yes, I do. Let me see. Okie dokie, guys, just a sec. I'm just stripping some cable as we speak. We need some neutral. And some live. So the cables are nearly ready, guys. So we need a permanent neutral coming to our base. So permanent live and neutral. So neutral is nearly ready. Moving on to live next. Next we need a permanent live. Okay, like so. So permanent live and neutral are just here now. Let's just connect these two up as well. Okay guys, so nearly there. I've just connected and I need to provide something else with it. Okay guys, don't be expecting all the looks and perfect connections right now. It's not the right time for all of that. But let's see. This is just for demonstration purposes. All we're doing is we're wiring it up. So, alright guys, so what I've done here is I've provided a permanent neutral, a permanent live, looped that permanent live to number 1, and then taken my load from number 3. So if it all goes to plan, if you close it back up and we turn it on, okay guys, so let's just turn it, plug it in, and let's see if it's going to work. Okay, there we go. Okay guys, so here we go. The base is searching for the signal, but we can manually turn it on and off, can't we? So if we press this button, do you think this bulb's gonna come on? This light's gonna work? Yeah? Is that a yes or a no, guys? Rajinder, I think you're saying no to Asif. The light's definitely coming on. Okay, let's see. So, I pressed the button, but the light didn't come on. RCD trip. No, so RCD did not trip, buddy, but the light didn't come on. Fault finding. Now we need to fault find to see why the light didn't come on. Let's have a look. Where is that little cover that we had? Guys, it's because we made a mistake, didn't we? Nobody was looking closely. So now what we did is we connected permanent live to number 1. That's not doing anything. In this case, the permanent live had to be with what? Where do we need to have a loop between? So the link is definitely there, Alan, but it's in a wrong place. The link is between permanent live and number 1. So it's not doing anything. So permanent live to common. So in this case, we need to connect it to common. So this is where how important it is to have a look at your device and the diagram to make sure that what you're using is it's right, basically, and you've understood it. Otherwise, you will be making mistakes like this, and it's very easy to just now move that cable from number 1 to number 2. However, it's the matter of getting to it, and sometimes we get very frustrated if stuff don't work for us. But then it's just a matter of having a quick look, taking one step back to say, oh, what have I done? Let's have another look. So we will have a quick look. Let's just rectify it. Let me just unplug it, make it safe. So it's unplugged, and we'll open it back up. And all we need to do is, as you can see, I have put that link between permanent live to number 1. All we need to do is shift that link from number 1 to number 2, and fingers crossed that should work as intended. Let's see. There we go. There we go. Let's have a quick look now. Okay. So, go on, guys. Let's see. Let's see if it's going to work. I'm about to press this button. I'm about to. 1, 2, 3. Go. Perfect. Okay, so it worked perfectly fine. As you can see that. And then turn it off, press it again. So yeah, that's how it works, really. That's how it works. And that's how we can simply just connect any of these thermostats to make our boiler system work. So guys, one of my tutor in college, we used to say only rocket science is rocket science, all the rest is easy. It's just a matter of understanding the basic concept of it, and then almost everything does become very easy. It's a matter of understanding it. But as I said, what I didn't want to do today is tell you guys that EPH connect 2 and 3, ESI connect 1 and 2, so and so Hive connect 3 and 4. That's easier said than done. Because tomorrow, if they change 2 and 3 to 3 and 4, then we have to memorize something different. So that's where it becomes very important to have a look at your device that you're using, have a look to see how it works, and then wire it up accordingly. That's how I see these things, and 9 out of 10 we can make them work, guys. I do some complex heating systems with multiple zones, multiple pumps, and in commercial setups, rather than investing into expensive junction boxes where they are designed to not have any backflow of turning extra pumps on when they're not intended, we can simply use that, do that by using simple contactors. So electricity is very easy where it comes to simple stuff, i.e. your heating controls and stuff like that. It's not too difficult. But if you guys need any help with it, by all means, let us know. There are quite a few people in our WhatsApp group as well, and if you are interested, just drop us a message, and we will put you in that WhatsApp group as well, and we will take it from there really. Any questions, guys, right at the end before I wrap up? Do we have any questions? Anybody? And in the next live, is there anything particular that you guys want to see? Did this session today, did it help? Or you want me to change it, improve it for the future? What do you guys think? Any feedback? Do we always need a wiring center? I would say no. I don't like using wiring centers, especially these types. I don't use these type of wiring centers, as I stopped using them ages ago. All I do is I go to Screwfix or CEF, buy myself an IP rated grey empty box, and we put all the cables into that using Vagos. Obviously label everything up, and that's how I roll, buddy. I'm not sure about you guys, but I'm sick of and tired of using these connectors with the screwdriver. Obviously you can buy the Wago ones as well, but to me, having loose cables in that box, and then I can end up putting some lights on those boxes. If I'm using a commercial, in a commercial setup or something like that, I can use these kind of lights and stuff like that for it, and take it from there. Guys, 10.1k likes as well, highly appreciated. Please do check our channel out. Those who have not followed, please do follow and check the rest of the videos as well. We are on YouTube and we do have some informative videos on there as well, so please do check our YouTube channel. It's called MHK Building Solutions. That'll be highly appreciated. But yeah, so that's what we do. Use standard IP rated box, empty box, so we don't have to put cables into these connectors, because it can be quite fiddly at times. And I'm sure on my TikTok you will find some videos where I've used those type of junction boxes, or the empty ones that I've just mentioned, and I'm sure you will like them. But any questions, guys, just drop me a line and we will take it from there. I really hope that today's session was helpful, and I'm here. We do go live very often, especially now that I have support from Asif as well, to manage some of the stuff. It makes it 10 times easier for me. So next we can have a look at the boiler in the future. Tonight is very late for it. We have Vaquera, we have a Worcester Bosch on here. I've also spoken to a friend of mine, and he's got a few boilers to hand over to us, so we can strip them down, have a look, and take it from there. But John, not a problem at all, my pleasure. It's always good to spend some time with you guys, and we go through it. A quick question: what smart heating is your favorite, Nest or Hive? I'm all for Hive right now. I know it's British Gas, but I'm not going to fall into the politics of it. I'm using Hive for my own house as we speak. Been using it for over 2 years, not had a single problem with it. Recently did a commercial job where we installed Hive system, smart Hive system, where we had 4 to 5 heating, 4 zones, and unvented cylinder zones as well, and it works as a dream, buddy. But yeah, Heat Miser seems to be very popular. Yes, it is. I think everybody's different. Whoever they're, whatever they use, and then they don't change because they used it and it worked. So there's no point reinventing the wheel for many people. I may be the same, to be honest. I do like a change. I don't mind it at all. But when something works and it's reliable, I don't see why we need to change it again, really. Improving, obviously these things are constantly improving and coming down in price, so Yeah, currently between Hive and Nest, I definitely go for Hive. If we have 2 zones on Hive, do you just need 1 hub? Yes, so the hub can have multiple zones added to it. Multiple heating zones, I should say. It can only have 1 hot water zone though, bearing that in mind. So if you have a property or a commercial job where you have unvented cylinders and let's say 4 or 5 heating zones, 1 hub is sufficient. You can install 1 dual channel Hive to cover your hot water and 1 of the zones out of those 4 or 5 that you may have, and the rest you just simply need to buy the thermostat and receiver, not a hub, and those will add on to your hub. So you can just pair all of that up. Guys, as Asif mentioned, please join if you are interested. Our WhatsApp group as well is running very smoothly, and there's a lot of useful information because we have tons of experienced engineers in there and ton of experience in the group, and they're very helpful, extremely helpful when you're stuck on a job or when you want to help others. That group really works out. Just drop me a line or Asif a line and we will send you the invite to the group as well, and you're more than welcome to join. Not a problem at all, guys. So that's all for today. I'll see you guys next time. If you have any suggestions, any feedback, please fire away now or leave me in the comments. I don't mind it. Constructive criticism, I'm all up for it. I'm no Mr. Know-It-All. I'm learning on a daily basis from guys like yourself out there and the experiences that you kind of see in the industry. So please do provide some feedback and we'll take it from there. Thank you very much. You take care. Enjoy your evening. I'll talk to you guys later. Thank you very much. Thanks for watching. Bye for now. Thank you.